Welcome back from the break, and let's continue. So our second guest speaker today is Professor Riikka Puuronen. Professor Puuronen is experienced ALD scientist, and also she has contributed on the community effort on the history of ALD a few years ago, collecting lots of information related to the history of the development of ALD technology over the years. So, Riikka, thank you.
Thank you, and thank you, Ville, for inviting me to give this presentation here. And it's great to see so many students here. I'm very positively surprised. And yeah, I have tried to make you a brief presentation of the history of ALD, because you need to know about it because you are in Finland and studying this field, and Finland has a central role in the world in this. I have basically 4 sections in this presentation. First, we'll go through the first commercial invention and first commercial application of ALD. Then it was atomic layer epitaxy and electroluminescent displays were that application. And here you have an example of an electroluminescent display making that yellow light all the time through the presentation. Then another phase started when another company was founded to develop ALD for new applications. So I'll talk about microchemistry and what happened after that. And this was all in Finland. ALD has been invented independently twice. So in our eastern neighbor, they came up with a technique, molekylijarna slavanje, translated mostly as molecular layering. So I'll very briefly cover that. But I was thinking that you were hoping for like a Finland-centered history presentation. So this is just a little very brief summary, and then also about how these two independent branches kind of met and joined. And I do expect that you are familiar with the fundamentals of ALD, so I do not explain anything about that. In the end of this presentation, I have collected pictures from encyclopedia chapter I wrote with Dutch colleagues, that if you are not familiar with everything, you can have a look at that. And those pictures are shared with Creative Commons license, so you can use them in all your works and theses, just citing the originals. Okay, first about the invention of atomic layer epitaxy, as ALD was known originally. Since the 1990s, gradually the terminology has changed, but the old folks still in Finland talk about ALE and atomic layer epitaxy. So this started in 1974. Tuomo Suntola, who formerly worked at the VTT Semiconductor Lab, he had been invited to company Instrumentarium to create some new technology there, basically to come and invent something. Well, how does that happen? You can read more in this essay I have written about that. It's in chemical vapor deposition. So all the story and background are there. But basically, 1974, Tuomo Suntola came up with the idea to make electroluminescent displays that are based on crystalline zinc sulfide doped with manganese. And he realized that they must have a very good structure to give the properties, and he came up with the idea of delivering elements to a surface one at a time, and the conditions should be such that the vapor pressure of the elements alone is higher than of the compound. So zinc in just metallic zinc has a higher vapor pressure than on zinc sulfide, and sulfur alone has a higher vapor pressure than in zinc sulfide. And he came up with the idea, and they built a reactor to realize it. At that time, they worked with a system where they had sources, hot sources, zinc at 360 and sulfur at 100 degrees centigrade in a high vacuum system, and they were rotating a glass substrate on these environments and observing optically whether they see a film growth, because they had calculated, Suntola had calculated that for a certain thickness, a purple reflection or how is it called, interference color is expected. And the work was successful. They observed growth indeed, not at the rate at which they expected. It was 2 rotations per second. This is a spatial ALD system, the first ever ALD reactor. So they were actually disappointed because they only got 1/3 of a monolayer per cycle, not monolayer per monolayer growth, but 1/3 of a monolayer per cycle already from these elemental precursors. Anyway, the concept was demonstrated, and also they doped it with manganese and were later able to show also the electroluminescence. And the first patent was filed on 29th of November 1974. So this is the start of ALD in Finland. That was made in an instrumentarium. That's company still exists. They are selling glasses and medical devices and so on. And it was realized that, first of all, so the first demonstration was successful. There was a patent, and it made sense to continue, but a lot of more resources would be needed. And this whole development project was sold to another company, Lohja construction company, also made their own TVs in the 80s. I don't know what they do at the moment, but they bought the whole development project and gave it more resources. And Suntola and colleagues realized that with these high vacuum systems, so that would be, I think, was it 10 to -6 pascals, so way different than what you just saw, applied materials. They realized they would need to work at a higher pressures and also in flow systems. So that's when the spatial ALD concept was discontinued, and they built this flow reactor. And here is Sven Lindfors, who was in Suntola's collaboration building it. And they had first started with experiments that were not so successful. So elemental zinc and sulfur, they kind of worked, but not really well. Then they went to compound reactants, zinc chloride and still sulfur. And that also didn't really work out even with hydrogen flown through it. But when they actually, it doesn't say it in the essay, but they borrowed a bottle of hydrogen sulfide from KCl, plugged it in and tried, and voila, it worked. So that's where the next breakthrough was taken, and later then also another, or soon after actually, another patent that's quite famous. And it was not only this electroluminescent layer, but also a lot of other development. So these electroluminescent displays, they consist of a insulator that also is made by ALD. In the end, in the product, it has been Aalto nanolaminates, aluminum oxide, titanium dioxide, and then the zinc sulfide that's doped with manganese, and again an insulator, and then other auxiliary layers, and other technology development around it. I think I jumped to, yes. So it took some time to have the devices operational, and the first public display of these electroluminescent displays was in 1980 in an SID conference in Boston, USA. It's an information display, something, Society of Information Displays, I think. And so this was a surprise there. It was unknown person, unknown country, and a hugely promising demonstrator there. They got an award for their presentation and lots of product inquiries. So it was clear that there were others who were doing similar displays with other technologies, but this was really significant. And lots of product inquiries, but they didn't have their product ready. So that was wasted. The first real proof of concept was in Helsinki airport. There was an information display board made in their pilot production line from 1983 until 1990 something, 15 years about. It was there operating all the time. And soon after that successful demonstrator, a factory was built. This is located here in Espoo. You can go and cycle around it. In Olarin Luoma, the address is also in the essay. So a new factory was built in the model of Silicon Valley, and with clean rooms and with the production facilities. So that all in 10 years. Then it was the time to reorganize the company. It was no longer research and development, but actually production and selling. So Tuomo Suntola had been leading until now, but then they took another person, Antti Piippo, to manage the business unit, and Suntola was remained as a chief scientist to look for other application areas for ALD. And along with this, these displays, a lot of new technologies have also been developed. They are using a high voltage to operate them. I think 200 volts are needed to make that and it required special electronics. And a few years later, a competitor of the technology bought it. So American company Planar bought this whole electroluminescent manufacturing, and of course this then meant other restructuring also, and for example that's when the company Elcotech was separated from this Lohja, and those who are familiar with the Nokia story in Finland, this is a company that's coming up there as well. Then Planar was making these devices in Finland, in their factories in US, and in the end only in Finland. So they stopped other factories, and this Finland remained operational. They decided to sell that as well, and a Finnish company, Benec, bought it. That was in 2012, and it's only about a year ago that Benec, or their brand name Luminec, they announced that they are stopping the operation. There's no longer the market for these products. So this has been a 50 years lifetime for a technology, starting from the first invention, going through the cycle of development, production, and the end. And so now you can no longer get these demonstrators, so mine is a valuable little thing. But that stopped. It doesn't mean that everything has stopped. ALD continues to live in many other things. And so this development, Suntola is the central person here. Of course, there have been hundreds of other Finns and probably foreigners also participating in it. It has been a very industrial thing altogether. There are patents. There's not the need to tell everything to everyone, but to keep things secret. But then there has been also ALD research started in many universities related to this. So for example, Tampere University of Technology, PKK, that's Helsinki University of Technology, Joensuu University, so I'm from PKK, Ville is from Joensuu, we are connected to these, and University of Helsinki, and also VTT Technical Research Center Finland was connected already to this electroluminescent display development, all the chemistry related to it. And of course this continues strong. Now at this moment, University of Helsinki is the most known for Finland for ALD reactant development and process development. Aalto, more applicable research or applied research. We have at least 10 groups, I think, that are working with it, and also VTT has their tools in operation. All right, that was a story with a start and an end. But then another story that is continuing. Microchemistry is at the heart of it. So 1985, when the production started for the electroluminescent displays, Suntola was the chief scientist looking for new application areas. This led to that a new company was started in 1987 as a joint venture between Neste company, that's an oil or renewables company nowadays, and this Lohja, who was the electroluminescent display developer then. And with two targeted applications, one was solar panels and one was heterogeneous catalysis. So earlier they had been making light from electricity, and then they would turn light into electricity. So kind of reverse thing. And the reactors that had been developed for production, they were not good for that. So the first task was to develop a reactor for research. And that is known as the F120 reactor. Here in the picture, how many of you have seen this type of a reactor, F120 reactor? Ooh, you haven't been doing lab works yet at Aalto, I see. So there are several of these at Aalto University. And so those were built for the company's own need. And very briefly about these two targets on which microchemistry kept on working for more than 10 years. Photovoltaics, they did show good results for example, cadmium telluride thin film photovoltaic cells up with record efficiencies, and there was also a factory built in France, and there were plans for going into production, but they were cancelled because it looked like it's not profitable enough. So these are business decisions. Then there are these side things that are coming up. So there's, for example, NDEAS Oy still working with quicksand simulators that were developed then. Jaakko Hyväreinen set it then up. And as for catalysis research at Neste, catalysts were made and tested and found active and found more active than reference catalyst by more usual preparation techniques. There were patents. I have taken here the number of the first one. It's from 1990. Scale up, publications, reviews, but the same story here. It didn't seem like there would be a route to commercialize these, really, and those activities were discontinued. I think it was in the end of 1990s. I'm not exactly sure. That's why I have the question mark here. And I myself started working with ALD in 1998 for catalysis, and so I was there when things were going down. Now I'm back at Aalto doing that because it has become popular in the world also in the meantime. But then, 1990, that was the time that Planer bought Benec. Planer bought the electroluminescent display manufacturing. So that was a time when microchemistry also reorganized. Originally, they had the license to do the work for photovoltaics and catalysis. But at this moment, Suntola renegotiated the use of his own patents for anything else than covered under the core electroluminescent work. So they started thinking further. Suntola had recognized semiconductor field already in the 80s as a potential application area that hadn't really led to anything yet, but that's when it really started, and they started selling those F120 reactors outside. I wonder if ours are from 1990. Pretty much that old, likely, and they developed a bigger reactor. So that F120, I think, is it the 12 centimeters that the reactor tube is? That 120 comes from something. 450, that's can fit 450 times 450 glass substrates, and it can also fit silicon wafers, not the 300 milli ones that you have just in your hands, but in the 1990s, 200 millimeters was already a really big one. And in 1994, at the Materials Research Society Symposium, Suntola was invited to talk, and he delivered the talk there, and they also had microchemistry had a booth with actual 200 millimeter wafers coated with ALD, so people could look and see the uniformity with their own eyes. And there was also a demonstrator of the conformality, and this is how it looked like. So this is aluminum oxide, TMA water process to my understanding, and you see that it's covering everything conformally. At that time, this was something special. At this time, this is no longer very special. We are doing something pretty more demanding, but already this was enough to really boost the interest in the semiconductor field. And that's where then developments were carried out further at microchemistry. Undercover, none of it is public, but then Also, there were several companies who wanted to buy microchemistry. So this little Finnish company, maybe about 100 workers or so, would they make reactors to Intel to do ALD? It was not credible. So there had to be a solution. And also Neste, as an oil company owning this business, that was also not credible. So there were interested buyers, and Neste wanted to sell, and eventually ASM, a Dutch company, bought Microchemistry, which then became ASM Microchemistry. And I was at that time a master's student at Microchemistry, and I remember this, turmoil also. In a way it was good, but then people were afraid of their jobs. And indeed, it took a few years, and then the manufacturing was moved out from Finland. But the good news is that the research unit stayed. There was skepticism also then, will it be only for a few years, but it is still here. And because, the manufacturing went away, many skilled people were freed. They had lost their jobs. And that again led to many of these persons thinking, what can we do? And two companies were soon founded that are carrying out with or continuing ALD. So Sven Lindfors, who was in the reactor picture from 75, he founded Picosum jointly with Kustaa Poutiainen, who was the money purse, and the previous speaker was from Picosum, bought by Applied Materials 2 years ago or so. And also Benec was founded not for ALD, but they started also doing the ALD work there. So these are in a way not spin-offs from microchemistry in any formal way, but maybe an informal way. So the same people who had been working with ALD in Finland for a long time. And here I just simplify things very much, saying that so from those times, ALD has been fast growing all the time. I did my thesis here. I wanted to stay in the field because I saw how rapidly it's growing, and it has been growing ever since. And this picture is from our joint review article 2013, when Ville was at the University of Helsinki, and showing how the number of publications has also started rapidly increasing. And this is a little bit old, but the newer versions would just show the same. And then there were many other companies that jumped into the business. I think I counted 30 at some point, and reactor technologies have gotten varied, and also the applications. The previous speaker talked about the high-K application, where the 20 years ago still our computers had silicon dioxide as the insulator in the transistors, and that was replaced by a, so to say, high-K material made by ALD. That was in 2007 that Intel made an announcement for this. So for this encyclopedia chapter, we actually mapped the public applications of ALD. So you can find more info there. And I think I'm probably running out of time. Yeah. ALD is growing and expanding, and ASM remains a global leader, I would say. Among those, Applied Materials is also one. Very briefly about the other independent invention. Already in 1916s, in St. Petersburg, there was a group of chemists at the university who started working combining chloride reactants with water reactants on porous materials for sorbents, catalysts, rubber fillers, and later also thin films for semiconductors. And they have written their own essay to complement this Suntola essay. So you can read that and find more details there. I started finding out about these when I was a postdoc at IMEC. Maybe I'll jump to this one. How have people learned about each other? Well, there was the ALE conference 1990 in Espoo, where Suntola met a researcher who came here from St. Petersburg. After that, he was invited to visit the group in St. Petersburg, and he did. And in both of these essays, you have their versions of how it went. And In the scientific publications, it has been a little bit not that fast, let's say. So in 2005, for this review article I wrote as a postdoc, I found out about these, and there's a table that is listing or describing some Soviet-Russian ALD investigations. But then things didn't really change in the academic literature. So in 2013, we started a history project that you mentioned that I have coordinated, where we had more than 70 scientists working, and we wanted to find out what did they actually do. And I think I'm gonna skip the rest. You can find all the details here if you want, but as a crown to the history project, then Suntola got the Millennium Technology Prize for his groundbreaking invention, and without the history project, without the work that we did, that wouldn't have been possible. His work didn't change, but how it's described to the world changed. And this I will just skip because of time limitations. And yeah, what I would want you to remember is ALD has very strong roots in Finland. It's part of the Finnish industrial history, and you see it in many applications worldwide. Today, ALD has been independently developed twice, and that's not seen in most of publications. So if you do research, this is something to bear in mind. And yeah, ALD is a still much developing field. That's it for me for today. And I have tried to record this, by the way. So if you want to listen again, that might be available if it succeeded.